Hello and welcome to Dan Makes Things. My name's Dan and today I've got something interesting to show you. I was recently contacted by Robo Educational and Research Robotics and they sent me over this brand new Arduino compatible board. Let's take a look. The Arduino is a microcontroller that allows you to connect various components to its GPIO pins and allow you to program logic to do interesting things. You can see a few examples at the top of the screen here. We have 3 Arduino compatible boards, and then this is an ESP32, which is a similar concept with Wi-Fi and slightly different pin arrangement. The board I've been sent today is the Robo Uno Plus. Its form factor is very similar to the Arduino Uno, but it has additional components and functionality that make it really interesting for prototyping and teaching robotics. So the Robo Uno Plus brings a lot of extra functionality to the Arduino Uno, including 3 Neopixels, which are addressable RGB LEDs, 4 push buttons connected to GPIO pins, a buzzer for output of audio, dedicated headers for an OLED display connected through I2C, and a JST-SH connector for I2C communication. It also includes a USB-C port for connecting and programming on the computer. You can see here as well there are a couple of switches, and these switches disable the buzzer and the Neopixels, freeing up the pins that they're connected to on the board. On the back you can see a clear pinout to describe which digital pins each of the buttons, buzzer and Neopixel are connected to. The board also has the details of each component and each pin printed on the board itself, removing the need to go and refer to a datasheet. The board comes as seen with no soldering required. If you do need to connect an OLED display, you can buy one and plug it in with the male headers here. I just happen to have an OLED display, but the pin arrangement is slightly different to the module they've used, so I've used some wiring and breakout headers to allow me to connect this to the board. The board comes with a number of example projects that can be uploaded to the board to demonstrate the functionality of the microcontroller and additional components. To use these projects, just download the files from the GitHub repository and open each one in your Arduino IDE. You can see the first example is a simple Hello World sketch with a counter. After selecting the Arduino Uno as the board type and selecting the right port, you can upload the sketch and open the serial monitor to see the output from the board. Let's take a look next at the Neopixel functionality with this project that creates a Christmas tree light effect that can be changed depending on which button is pressed. This is a great example of how the Neopixels can be leveraged to generate interesting effects and could be extended to work with an external Neopixel strip or board. The next sketch I tested is an alarm simulator. You can enter a sequence of button presses, and if the sequence doesn't match the expected pattern, the buzzer sounds and the lights flash red. Another good example of how to use the internal components, as well as some more complex logic to learn from or use in another project. Next, I wanted to try out the screen, and you can see here that we can output text to the screen and use the buttons to adjust the display values. After trying out the demos, I wanted to see if I could use some of my own work on the board. I have an old project that I'd love to see working on this board, so I downloaded it from GitHub and made some adjustments. This project, called Braille Speak, takes text input from the serial monitor and converts it to a series of tones, effectively creating a pseudo-language that can be understood by machines or us if you really wanted to. It converts each character into a mapping of 2 tones, representing the left and right halves of a Braille character, hence the name. Those tones are then played in succession. This repeats until the full text has been output. It also supports Neopixels and can be run in silent mode, with different colours representing each tone. I also added support for the screen to output the text it received from the serial monitor. You can see when I send the text via the serial monitor, the buzzer sounds, the LEDs flash, and the text shows the output. Perfect. The switches also give us the option to disable some of the components. Let's turn off the Neopixels and just use the buzzer. Next, let's turn off the buzzer and activate the lights. And finally, just the screen. Of course, it would help if I flicked the switches the right way. I love that this all works on a single board rather than having to wire in separate components. This makes the project much more portable, especially if I had the correct screen for the headers. Overall, I'd say this is a great board for beginners and experienced Arduino users who are looking for a portable board that offers this additional functionality. The ability to add I2C modules is also an option that could deliver a lot of extra features to projects. For me personally, I can see this being something I can take with me to events and workshops to demonstrate projects without having to carry around a bag of components and worry about wiring. It would also be a great first board for teaching STEM subjects to a group of students. Please consider supporting the project if you're interested. The links are in the description. Thanks for watching.